Hello class, let's dive into defining data mining and its motivations. So over the course of this and 2 other follow-on lectures, or follow-on pieces to this lecture, we have 5 core learning objectives. First, we want to define data mining and differentiate it from other fields of study, and define at least 3 kinds of data that we're going to try and analyze, or at least get the tools to analyze as part of learning data mining. Then I want to talk about APIs and what kinds of APIs we may expect or engage with, and what kind of data formats we may deal with. Then talk about frequent item set mining and its applications, and then why counting frequent pairs is so valuable for the frequent item set piece. And we'll connect that, these 2 objectives to the larger case for data mining as we go on. This part of the lecture, though, is going to focus on these first 2 elements about defining data mining and the kinds of data that we get to deal with. So first, data mining, what is it? It is a relatively nebulous term when you talk about data science and data mining. This term gets thrown around a lot, but really what are we doing in the data mining course? So really, the goal here is to extract knowledge from data. Because not everything that is data, not all the data that you have, equates to knowledge. If we're going to create knowledge from data, we have to do a couple of things. We have to collect the data, we have to store it in some way, and then we have to analyze it in some way to extract the useful insights that we care about. Now, over the course of the semester and over the course of your program, the kinds of experiences you get from other classes are useful for this kind of class. So first, when we talk about data collection, this is the purview of web programming, APIs, or if you're doing other kinds of work, it's like survey work. From the storage perspective, this could be informed from your database classes or IT kind of classes where you're talking about data lakes or Amazon Web Services. Where does that data go? But when we talk about data analysis, we're trying to analyze the data to extract this knowledge. That's where really the tools for data mining and data science come from. So a lot of this course will be focused on this last point, though in this part of the course, and this week actually, I'll give some overview of the APIs for data collection as well. So this class, INST 414, is about the combination of data mining and the web, really. So we'll talk about the tools for data mining, how do we extract useful insights, and how do we get this data from the web. Mostly this pipeline is going to be run through APIs of some form, but also data that you've collected or people have collected from the web for you over the course of this semester. But it's these 2 main pieces that we'll talk about. Now, first, what does it mean when we talk about web data or web scale data, which is where most of we're going to focus our data mining techniques on over the semester? So the main point here is that web scale data, real world kinds of data sets, especially in the modern world, are often diverse sets of data, generally that are too big to fit in memory. So in this context, we want to understand, well, what is data mining when we're going to be using this web scale data. So as I mentioned, the goal with data mining is to extract knowledge from data. What is this knowledge? This knowledge is some collection of insights, and we can say something about the kinds of insights we want. We want insights to be valid. That means the insights that you extract should hold on new data with some certainty, that the world today may be different from the world tomorrow, but not hugely different, so our insights from today should hold tomorrow. Now, certainly there are issues with that. The moment TikTok changes its For You page algorithm, maybe things change about your insights, but generally the goal is to have valid insights. You want insights that are useful. That means these insights should actually help guide somebody in taking action. This is why I push you so much on your Medium posts to motivate them with some decision that you are trying to help somebody make. Because if that's your motivation, then naturally the insights you're looking for will be actionable. That's how we get useful insights. Next, your insights should be unexpected. They shouldn't be trivial or obvious. So if you want to understand something about population movements, it's not entirely useful to say, well, there are a lot more people moving on the road in New York City than there are in Boise, Idaho. That's a clearly population-driven insight that's just not hugely useful. We could have figured that out without any kind of real analysis, or we might have expected that with any kind of real analysis. Instead, you might want to say something about, well, how are different neighborhoods in New York driven or how are people on the road in different neighborhoods of New York driven by socioeconomic status? Or what's the different distribution of types of cars in New York versus Boise, Idaho? Maybe you see way more SUVs in Idaho than you do in New York. These are maybe less obvious insights that might still be interesting if you're looking at things like gasoline consumption per capita or something like that. And then finally, the insights that we're looking for should be understandable. You should be able to communicate the patterns that you are identifying or characterizing in your data to some person who can then digest them and take action on them. So this is also why I am having you do these Medium assignment posts throughout the semester, because being able to communicate understandable insights, interpret them for non-expert stakeholders, is a hugely important part of data mining. So when we talk about data mining, we can really think about two different kinds of tasks in data mining. One is descriptions. We want to understand or say something about the state of the world. When we say, in this example that I gave you about SUVs, distribution of SUV type cars in Idaho versus New York, or Idaho versus Washington, D.C., that's a descriptive kind of task that gives us additional insight. We want to understand something about bias in the world, so we're looking at we're describing how people engage across socioeconomic status, or how the payroll protection plan that came out as part of COVID, we get to describe where the majority of that money went. That's hugely useful for extracting insights, but it's primarily descriptive. The second kind of task we might do in data mining is prediction. So we take some data that we have now, or some data that we think will inform us about what will happen in the future, and we use that to predict these next steps. So, breaking down description, maybe this is finding similar instances of things, so we can describe this is a kind of item, what are similar kinds of items to this, if we're on Amazon and looking to recommend you items. We can extract clusters of data saying, well, these kinds of users all watched these kinds of YouTube videos versus these other kinds of users who were interested in a different kind of, or a different topic. They watched a different kind of YouTube video that informs us about how we recommend content to them, or how we do interventions if we're trying to make the information ecosystem higher quality or safer space. We might describe the structure of the data, so where is this data distributed? What are the models that are driving aspects of the data? Or we can just identify important elements of the data. So maybe this is, what is the major driver of educational attainment in the United States? That's probably socioeconomic status, more so than IQ. Things like that. Those are all descriptive tasks. In contrast, prediction is essentially, one example of this is predicting the future value of a metric given a current metric. So this is like stock market prediction. A metric might be, current price of a stock or current price of an equity or asset. Well, what is that price going to be tomorrow? But it could also be predicting a user's rating. So not necessarily my rating of a particular item based on my rating today. Maybe it's, can we predict a user's rating for an item given the other kinds of items that they've liked? Can we predict whether a particular ad that you are shown will be clicked on? What is the click-through rate for a particular ad? What makes an ad effective? Or, if we're trying to allocate our advertising revenue, we want to make sure that the ads that we're paying for will go in front of people who are likely to click them, who are likely to want to see them. Another way to think of this is about recommendation. So rather than just predicting some value of a metric, we want to recommend items to you, recommend videos to you in your Netflix queue or in your YouTube queue, or recommend songs to you on Spotify. How might we do that? How might we predict whether you will like a new element of thing? We can't necessarily describe whether you'll like a new element of a thing because we don't have data for that yet, but we can predict it based on other things that we've seen. So those are what we're trying to do with data mining. Describe the world or predict something about what the world might be. Let's talk a little bit about what data mining is not. So data mining is not databases, though data mining includes aspects of databases, as I've talked about in terms of storage. So it definitely includes this database question. It could include analysis of databases. Databases, though, generally, if you look at the field of databases, generally providing analytics and running complex queries on large data sets, or how do we store data in a way that's efficient and effective. But that's not necessarily what we're doing in data mining. Not all data that we're going to care about or look at has to be nicely structured or is structured in a database. So for example, if you are looking at the text of articles in newspapers, you have not necessarily clear structure here. There is visual structure, so if you look at the New York Times article versus this Washington Post article, you can see up at the top, both of them have some byline that describes who wrote them and when they were written, but they're not quite the same format, and if we aren't given a database for these things, then one of the things we have to do is extract the structure ourselves, rather than have the structure given to us that we might have in a database. Data mining is also not the same as machine learning, though they do overlap. So certainly training machine learning models, getting data from machine learning models, applications of machine learning models, data mining can include those things. But data mining can also be about extracting and visualizing the insights, which may not require any kind of machine learning. And not all the insights that we care about, or not all the insights that might be interesting, require sophisticated modeling. So if we're doing primarily descriptive kinds of work, maybe we don't care about classification or clustering so much as identifying unexpected kinds of associations, which we'll talk about in the frequent item set mining portion of today's lecture as well. Say, for example, we have these different articles from two different news sources, and we want to track something about authors of news. So journalists tend to write for multiple news outlets. You can go to websites like muckrack.com to see where a particular journalist has written articles for, and maybe we want to mine something about, well, who is more likely to write for the Washington Post and New York Times versus some local newspaper. We can do that based on just descriptive analytics without having to rely on sophisticated machine learning models, especially if the database already explicitly says this article is written by this person. So that doesn't require sophisticated machine learning here. So when we talk about data mining, one of the major parts of this course is to help you get the techniques for applying data mining on real-world data sets. So what does this mean? Well, first, when we are talking about web data, which is where a lot of our data mining content comes from, well, the web is really big, so we have to deal with large-scale data. So web-scale data is something I've already talked about. But data also comes in many different forms, so we can have sort of content that you might expect, like text or images or songs or videos that people share on the web, so your standard kinds of content that you may see on a social media network or a social media platform. But we also have network data, which is what we'll talk about in Module 2. So there's lots of interesting networks that we can extract from the web. Your friend-follower networks, citation networks, all kinds of things there. But there's also behavioral data, so like click log data. So how do people click through ads on a platform or engage with different websites on a platform. So analytics for websites is a hugely popular area of analysis to understand, well, which parts of your website are seeing the most traffic, or why are people going to this part of your page rather than this part of your page. You can analyze that through this behavioral log data. So content data that we've already seen, so it could be textual data about an article. It could be your social media content, which can include text, images, video, sounds, all these kinds of things. Network data may be friend-follower graphs, but it could also be interactions between websites, or in Wikipedia, interactions between articles, or interactions between pages. The click log data, as I mentioned, could be, where are people coming to your website from? Are they coming, did they find your website via Google? Did they just organically type in your website name? What country are they coming from? What are they interested in when they go to your website? This click log data is hugely useful and tends to be quite sensitive data for companies, because maybe you're looking at particular timestamps, very low-level timestamps for when a particular IP address visited a particular URL in your site. Where was that IP address from in terms of city, state, country? A lot of that information is sensitive but hugely valuable. The kind of data that we deal with varies a lot in structure. So you might have structured data, like databases that we've talked about, that have very clear, this column contains this type of data has this meaning. It could be totally unstructured data, so that's raw text that maybe you've just scraped from websites or collected from Twitter accounts. But it could also be images, so it's not necessarily clear what kind of data is in an image or in a video. And it could be somewhere in between, where we have some kind of structure, but it's not fully structured. So JSON's a good example of this, where we have keys and values, but there's not a schema that enforces any kind of typing that says, well, this kind of value has to be this kind of type. Same thing with CSVs. XML is also somewhere closer to structured data, but not as necessarily as rigorous or draconian as typed databases. So databases maybe you've seen where we have lots of relations between objects that have a lot of particular attributes. Unstructured data may be raw text or images like I mentioned, or your email or video. Semi-structured data is CSVs, XML, JSON data that maybe doesn't have explicit typing information. You'll deal with all these kinds of data over the course of the semester. You have the opportunity to. Other kinds of issues with data in this course is that data sources are dynamic. They're always changing. So this question of validity is an important one, because the content that's on YouTube changes from moment to moment. What you might be recommended on YouTube might be very different than what your neighbor is recommended, or what you're recommended today may be different than what YouTube is going to recommend you tomorrow. And you can imagine this very easily with something like TikTok, where there's constantly new content being added to the platform. Your For You page is constantly adding or constantly evolving based on not just the new data, but also how you're interacting with the platform. So how do we deal with this kind of evolution? And in this context, not just is the data always evolving, but you might have data that never ends. So the kinds of things that you do with data streams is going to be different than how you deal with data that's just snapshots of data. Click log data is a good example of streams, because people are hopefully always visiting your website. Social media is a good example of this, because people are always posting new content. Same thing with live streaming like Twitch or Discord or YouTube Live, where people are pushing new content out as it happens. Other issues that we encounter with data is that data is not always directly accessible. The kinds of data that exist in one data source may not be easily aligned with data from other data sources. There could be hugely valuable information about your users that you want for your e-commerce site, but maybe they're hidden behind some paywall or are sensitive and protected for privacy reasons that you can't get. And when we're talking about trying to extract insights from very large data, so like all of YouTube or all of Twitter, or even demographic data from census data, that's hard. For social media data or online data, one of the things you'll quickly see is that, well, the vast majority of data aren't useful to the vast majority of people. And that's not to say that every single piece of data or a given piece of data may be useful to no one, just that the interest profiles of one user may be vastly different from the interest profiles of a different user. So they may not see any similar data that they care about. You may not have access to all the data that you want. So in the previous slide, I showed issues of not all data being accessible. If you want to connect data sources, that might be difficult. You may not have full access to the data. There's lots of examples for that for privacy protections. The way you access data is also itself kind of hard. So imagine that you're trying to find pictures of cats. Well, how do you describe the picture of the cat that you want? Well, you have to describe it using generally some query language or some set of keywords, which maybe isn't necessarily as aligned with the modality of the data that you care about. I mean, only recently has Google done a better job in doing image search, where you can search for images based on queries of images. So there are difficulties here. An interesting example here where not all data is useful is this study about the Wikimedia Commons, where they looked at 10,000 images that people had posted to the Wikimedia Commons. So these are freely usable images that you can go and use for any reason that you want, all common licensed or freely usable public domain images. And what they found was 35% of these images, we're talking about only 3,000 of these 10,000 images, were ever used by anybody outside of the person who had uploaded them. So for the vast majority of images here, nobody else had ever used. Other studies of this have shown that actually most of the time no one has ever even seen these other images besides the person who initially uploaded them. So given that so much of this data is unknown or only seen by a very small handfuls of people, how do we actually extract insights? How do we help people find what's useful in those large sets of data that maybe no one's ever looked at, or YouTube videos that no one's ever seen after they were first uploaded? So to summarize, what is data mining? Ultimately, it's about making data that we have more useful, extracting useful insights and extracting knowledge from the data that we can collect. In this course, we focus on web data because we're looking at real-world data sets, lots of data sets that you can get, lots of web mining or lots of data mining that you'll be doing in the real world may come from the web. But that's certainly not the only place you may find data. So you may find data for mining from surveys, from census data, from click logs. That's not necessarily the web, from sensors, lots of places to find data. The web is a convenient place for large volumes of data, though. So that's what we'll focus on in this class, trying to make web data more useful. So now hopefully you've got some good insights about what is data mining, how is it different from fields like databases or machine learning, and talk and have some idea about the different kinds of data that we look at. Click log behavioral data, raw textual data, network structure in our data, all these different kinds of data that we may deal with. So that's it for this part of the lecture. There'll be the next part about APIs, and then I'll have the last part of 3 for this week on item set mining. So if you have any questions about any of this content, post it to the Module 1 discussion forum.